No, that's some bold letters. My name is David Dawson. I give a presentation on the webinar for process safety. The webinar was given by Louisa Nera. She is currently the technical director for the Center for Chemical Process Safety for the American Institute of Chemical Engineers. Prior to that, she worked for about 15 years for Bayer, notably as the director for risk management and compliance, and also the manager for crisis management and process safety. And so she has worked within the process safety field for quite some time. The CCPS was formed in 1985 as part of the American Institute of Chemical Engineers. It was actually formed in part due to the disaster that the first part of the webinar covered, which is the Bhopal industrial accident, which I will get into in more detail. It has over 145 member companies of many different industries, like petrochemical and pretty much everything else, including government agencies and regulators. And it is organized as a nonprofit technical organization. And again, the Bhopal is the site of what would be the biggest industrial accident. And I think the reason this webinar included that is that it is the biggest highlight you could imagine for the importance of process safety. And so it is a chemical plant that was located in central India in Bhopal, and it was ran by a subsidiary of Union Carbide India Limited. And the plant manufactured a pesticide that was marketed under the trade name 7, which was their name for chemical carbaryl. The incident in question occurred at December the 3rd, 1984, and it involved the release of a particularly nasty toxic intermediate in their process called methyl isocyanate. And one of the reasons that she gives for going over this particular event is that the majority of college students now were not even born at that moment or were very young. Myself, that was 2 days before my 8th birthday. And this is the reaction that was carried out at the plant to produce the carbaryl, which is number 5 on the slide. And so you would react methylamine and phosgene to get to the methyl isocyanate, which would be reacted with the 1-naphthol to get the carbaryl as their finished product. The reason that the methyl isocyanate is so dangerous is that it has a relatively low boiling point at 39.1 degrees Celsius, which gives it at 20 degrees Celsius a pretty high vapor pressure of 348 millimeters of mercury. And also, you notice this vapor density relative to air, so it's about twice as dense as the surrounding air. And then the last 2 entries are to deal with the toxicity of it. This one is toxicity limited value, a time-weighted average, which has to do with exposure over an 8-hour workday over a 40-hour week of 0.02 parts per million. This one is like the lethal concentration to kill 50% of a population of rats at only 5 parts per million. So this is an illustration of the setup of the storage tanks where they stored this methyl isocyanate. They had 3 tanks that could hold up to 41 tons of the methyl isocyanate ENCH. And the particular tank where the disaster occurred was filled to capacity. And one of the problems they had in order to keep any possible side reactions under control is that it was supposed to be refrigerated down to just under 5 degrees Celsius. But at the time that this occurred, the Freon used as a refrigerant was actually taken out of the refrigeration system to be used in another part of the plant just to save money. And so it wasn't refrigerated, and so it was closer up to that 20 degrees Celsius mark. And then what happened is that somehow, and there's a lot of controversy over how it happened, water got into one of the tanks, and there was an exothermic side reaction involving water. And one of the theories about how it got in, it was either it was washing some pipes nearby, but Union Carbide has claimed that the valves they used, it was pretty much impossible for that amount of water to have gotten into their tank. And then there's also, they maintain it was an act of sabotage by a disgruntled worker who took a pressure valve off one of the tanks and just flooded it with water. But what this helps me illustrate is the number of the safety systems that were in place. Again, we've already mentioned the refrigeration was not active, and so then we had the scrubber for the vent pipes coming out of the pressure release pipes coming out of the tank. The scrubber also was down for maintenance and was operating something like 1/4 of its effectiveness. And then as it comes out, it goes through this water curtain that was just meant to sort of to catch it out of the air. The water curtain didn't have enough pressure to actually reach the flue gas where it needed to be. Then as a last resort, there was a flare tower that also was down for maintenance, so it was not operational. So basically none of the safety measures in place to deal with this spill were actually working. And the results is that about 31 tons of gaseous MIC entered the atmosphere under pretty stable conditions. And the plume, again, because its density was about twice that of air, it just sort of sat there like a smoggy cloud along the ground. And the estimates are from 200,000 to 500,000 people were actually exposed to this nasty cloud of both the methyl isocyanate and the other side products that were all in this cloud. And the estimates, again, are between 14,000 to 18,000 deaths. It's hard to get a really good figure because they were just kind of doing mass cremations and throwing bodies in the river, and so they're not really sure. The confirmed number is about 4,000, but most agencies believe that's way too low. And even to this day, because the Union Carbide was kind of kicked out of the site, they didn't even clean up the chemicals that were left there, and they're still just there continuing to contaminate the area. And, so the factors that ended up leading up to this, there was just a lot of pressure to reduce costs, which was one of the big reasons they had moved the Freon out. And there was also an issue that there was pressure to use local components in the construction of the site, and there was a lot of that there. The quality of the various valves being used was not quite up to the standards that the factory was designed for. There was also not even the proper personnel, the properly trained personnel being present. A lot of them had moved out because at this time the pesticides were not in as high demand, and I think that is one of the reasons they had so 41 tons of this stuff just sitting there in a tank. And so it's like they weren't worried about it, I guess, because they weren't really using a lot of it to make the final product. So it was just kind of sitting there, and then they were siphoning off resources to take care of this stuff to other, I guess, more profitable parts. of their operations. And also even, a lot of times the personnel there had to make do with English manuals when many of them didn't speak or read English very well at all. And there was a refrigeration issue, and then the mitigation factors, the scrubbers and flare system were both either not operational at all or at least very inadequate to the scale of the disaster. And also the population, it was built in the middle of a pretty crowded residential area where they had even like ramshackle dwellings built all the way up to the fencing around the factory. It was an area of really high population density. And then there was virtually no communication to the responding authorities, like the hospitals, the local hospitals and emergency workers had no idea how to deal with this kind of contamination. They had no idea even what was going on. The response was really slow. So they had no real plan in place to deal with something of this magnitude. And again, this is used to highlight the importance of effective process safety management as opposed to just occupational safety, because the scale of the consequences can be very high. And so the management style to focus on these factors, and these are in order of importance or in order of effectiveness, and that you would hope that you could prevent these sort of incidents altogether, but if they do happen, you want to be prepared, have the proper systems to mitigate it, have your response to such a disaster planned, and then if all else fails, at least be able to restore things. And again, that's what the Center for Chemical Process Safety is all about. It's about eliminating these process safety incidents. And through their website and other resources, they have many publications. You can order books, and they do conferences and courses on process safety. They have their newsletter, the Process Safety Beacon, which is available in 31 languages, and they have many other online training courses and webinars on other incidents, some very serious too. And they have a presence around the world, especially in Latin America, Asia, the Middle East, Australia. And this is a list of the resources